Ever get that feeling? Like maybe our universe is way stranger than we can even imagine. Well, that's what we're diving into today. String theory.
It's a theory that throws out our usual ideas about, well, everything. Like, what if the universe isn't made of tiny particles,
Hmm.
but teeny, tiny vibrating strings instead?
Wild stuff. And we're going deep, using excerpts from a real textbook, like the kind they use in physics classes at UC Santa Barbara.
No simplified explanations here. We're in the weeds with this one.
You got it. So first things first, w- what are these strings anyway?
So in particle physics, it's all about these point-like particles, right?
Yeah.
String theory says, nope, what if we've got these little tiny vibrating strings instead?
So instead of picturing like two billiard balls colliding, now we're talking about what? The snap of a rubber band? It's a
Yeah.
completely different way of thinking about things.
Yeah, exactly. And this change from points to strings, it leads to some pretty wild consequences.
Like what?
Well, for one, we might need more dimensions than we thought to make the math work.
More dimensions. How many more are we talking here?
A lot more. We're talking 26 dimensions in bosonic string theory.
26. Okay, hold on. Before my brain melts down, can you explain what bosonic even means?
Good question. It's a mouthful, for sure. Bosonic string theory basically focuses on one type of particle called a boson.
Okay, so 26 dimensions, and they're all just hanging out in this textbook. How is that even possible?
It's not like there are 26 giant dimensions we just haven't noticed. Think of it like this.
Mhm.
Imagine a garden hose. From far away, it looks like a one-dimensional line.
Okay, I get that.
But when you look up close, you see it had a two-dimensional surface.
So you're saying these extra dimensions are hidden from us, but they still affect how things work on a deeper level.
Exactly. And how these extra dimensions are curled up, well, the math behind that can get pretty complicated. But basically, we experience our familiar three spatial dimensions. While these other dimensions are so small, they're invisible to us.
Okay, I think I'm starting to get these tiny curled up dimensions, but this textbook keeps going, right? Now it's talking about D-branes.
Yeah.
What are those?
This is where it gets really out there. So string theory math predicts these things called D-branes. Imagine them like surfaces or membranes in these higher dimensions.
So kind of like sheets or planes, but within those already weird curled up dimensions.
Yeah, exactly. But here's the thing, D-branes, they don't follow the same rules about dimensions that we're used to. Well, we think of objects having a certain number of dimensions. Your phone is 3D, a piece of paper is 2D.
Hmm.
But D-branes, they can have different numbers of dimensions. Some might be 2D, some could be 5, 10, who knows?
Okay, so let me get this straight. We could be living in a 3D world that's part of a D brain with like a totally different number of dimensions, and that's all tucked away inside those 26 dimensions. My brain hurts.
And that's not even the wildest part. Get this. The textbook suggests our entire universe could actually be on one giant D-brane.
Wait, are you saying everything we know, everything we can see and touch, it's all just one slice of some higher dimensional thing?
That's one of the mind-blowing things about string theory,
heck.
and it comes right from the math.
Wow. Okay, so where do we go from here?
Well, it gets even weirder with this idea called T-duality.
T-duality, huh? What's
Yeah.
that all about?
Okay, so imagine two universes both doing their string theory thing. One universe has a dimension that's super small, curled up tight, like that garden hose we talked about. The other universe, it's got a dimension that's huge, totally expanded.
Okay, I'm picturing it.
T-duality says these two universes that look completely different could actually be the same, physically.
Wait, really?
It's like they're two sides of the same coin, just seen from a different perspective.
That's wild. So something that looks big to us could be tiny from another point of view.
Exactly. It's like the universe has this hidden symmetry where size is relative.
Okay, I need a second to process this. We've got vibrating strings, hidden dimensions, D-branes with their own rules, and now T-duality is messing with our ideas about size. It's like string theory is saying our normal intuition about the universe is totally wrong.
It definitely makes you think differently. But the really cool thing is, these crazy ideas, they come straight from the math of string theory.
So it's not just physicists making up crazy stories. There's actual math behind this.
Oh yeah, absolutely.
Yeah.
And that's why string theory is so interesting. It's not just random cool ideas. It's got serious math backing it up.
Right, right. Of course, the math is super complicated, but it's all based on real physics and mathematics, right?
Exactly.
Well, we've covered a ton in this deep dive. We've explored these vibrating strings, the 26 dimensions, those strange D-branes, and this universe-bending idea of T-duality. What else did this wild textbook have in store for us?
One of the biggest questions it asks is, What if the universe, the one we can see and measure, what if it's just one tiny part of a much bigger, weirder reality?
So, like, it's that feeling you get when you look up at the night sky and feel how huge the universe is, but even bigger.
Yeah, exactly. String theory suggests maybe there are tons of universes, each with its own laws of physics.
Wow.
It's pretty amazing and a little scary to think about.
It really makes you rethink everything, you know? And what I love about this deep dive is that we've only scratched the surface of string theory.
It's true. We've only just started to explore these ideas.
It's like we've had a glimpse of all this amazing knowledge just waiting to be discovered.
And that's what makes it so fascinating.
Yeah.
String theory gives us the tools to explore those mysteries, to learn even more about the universe.
It takes us to the edge of what we know and what we can even imagine. So, to everyone listening, if you've ever wondered about the universe and our place in it, remember there's so much more to learn. Even though this was just a deep dive into string theory, it's really just the beginning.